Let us consider wireless networks. Wireless networks, wireless LAN for the IEEE 802.11 Wi-Fi standard. Such wireless local areas networks, also called wireless Ethernet, that is a very popular wireless network technology, which is classified under the name Wi-Fi and specified in the Internet standard 802.11. This Wi-Fi standard IEEE 802.11 was developed to enable the user to interconnect with each other in a wireless way and to allow and to enable wireless data transmission on such local networks. So the standard specifies the communication protocol on the lowest layer of the wireless network. So it provides the possibility that data can be sent by radio signals. So 802.11 Wi-Fi is now the most widely used communication protocol in wireless networks. If we consider such a wireless local area network, then there are three different types of components. We have the mobile devices, that are the devices, the smartphone, the pad or the laptop that is able to transmit data by means of the Wi-Fi, of the wireless local area network technology. Then there is an antenna, the Wi-Fi antenna, that is to enable to transmit and to receive data by means of radio signals. And then, most important, the base station or access point, which allows the devices to connect to each other and to become connected to the internet. Here, this is the base station, with the antenna, with Wi-Fi antenna. So the Wi-Fi enabled devices can connect to the station, can send data, and then the access point is able to interconnect different mobile users, but the access point is also able to interconnect mobile users to the stationary internet. Of course, there are some basic risk securities working in wireless LANs. So the major security risk of such Wi-Fi's is the problem that's fundamentally difficult to protect messages and to protect privacy in wireless networks. The reason is simple. The data packages are transmitted via radio links, and anyone who is in the range can receive them and then can analyze the content or can try to manipulate this. So this security risk is a constant danger if one uses such mobile networks, and one has to be clear that there's a permanent danger that all the data traffic is monitored. So safety precautions are essential. Special care must be taken when one is using public Wi-Fi networks in a hotel, in an airport, a railway station, or wherever such access to the internet via such a public Wi-Fi is offered. There are some well-known security mechanisms that are used when wireless LANs are used. So there is Wi-Fi encryption, which is partially unsafe. We will discuss this later. There is MAC address filtering, which is unsafe. There is hiding as a technique of the security mechanism of hiding the SSID. So the name of the mobile network is also to be considered unsafe. Generally, caution when serving is one has to use TLS SSL encryption, which is also used, for example, in the stationary internet when we work with HTTPS instead of HTTP. Moreover, there are more security techniques, for example, the use of encrypted data tunnels, so-called VPNs, virtual private networks, which also are recommended to use when one is connecting to the network via such a Wi-Fi. Let's have a closer look to these well-known security mechanisms, and let's start with Wi-Fi encryption. This is an encryption of the traffic in a wireless network on the lowest network level. So the typical methods which are in place here is WEP, WPA, and WPA2. I go into more details of WPA2 because the two others are not considered to be safe. So WEP and WPA are now considered unsafe, and when possible they should not be used. Why they should not be used? The WEP, for example, can be cracked within minutes. So complete access to the network is possible to all the data that are transported there. If we look to WPA, it's prone to the cracking of the individual data packets. So it's possible to at least small parts of the messages that can be read by the attacker. For that reason, let's have a closer look to WPA2, which is currently widely used as encryption method. If possible, you should use WPA2 CCMP and not WPA2 TKIP. These are different encryption methods coming with WPA2. Recent research but reveals also a sign flow in the WPA2 protocols, which allow decryption, which allow replay and forgery of packages. But this is a very recent research, so the corresponding attack focus on a special scenario for retransmission of messages during a session key generation. Of course, for any kind of encryption, a key needs to be generated, which is needed for the encryption, and that needs to be exchanged between the users. So key reinstallation attack, the crack attack, revealed server bugs in several WPA2 handshake implementations. So, for example, temporary session key is not reinstalled, but replaced with all zero session key. Session key is predictable and allows packet injection. So these are the weaknesses, so that also WPA2 in some implementation can no more considered to be secure. Interestingly, the attack does not reveal the Wi-Fi password. The crack incident showed that even mathematically proven protocols could be affected by design flaws which have not been covered by the underlying model. When such a protocol mathematically is proved, there are some assumptions made, and on the basis of this assumption, then a mathematical proof is given that this method is secure. This was done for WPA2, but because of the special situation, the people find out that the model was not complete, an attack was possible. So experts stated that all clients have to be updated to secure WPA2 again, the update version of this protocol to at least make it impossible to use this type of attack. Additionally, besides of updating the clients, when using WPA2, one should use strong passwords, because weak passwords can be cracked in a short time, and then fully network access is possible. Perhaps you remember that in week 2 we had an excursion which shows that with a speed rate of 1 million operations in a second, it is easily possible to get access to the network. And then one should use a unique network name. This is the ESSID, as frequently used SSD ease the deduction of the passwords. WPS, another part of the Wi-Fi encryption, this is the so-called Wi-Fi protected setup. This is a process for supposedly secure key exchange. So it helps the user to implement these methods. So one has to entering a password for a VPA, VPA2, and this is made easier by means of a simpler method. So one has to enter a PIN and then pressing a button on the router, but the method, which should help to increase the security, to make the implementation and the configuration, the security configuration more easy, but methods have major vulnerabilities that allow penetration into the network. For that reason, this method, the VPS protocol, should be disabled on the router, not to provide an attack point. When I mentioned the well-known security mechanisms, I spoke about MAC address filtering. What is MAC address filtering? It's frequently proposed security method which allows only specific devices to connect to a network. And in this way, the idea is to exclude cyber criminals. The idea is that that the router needs to be configured in such a way that the hardware address of each device must be registered in the router before the router connects that device to the mobile network. But it was shown that the protection in this way, by means of MAC address filtering, is not effective enough. And the reason is simple. The reason is that the hardware address of a device can easily be changed, and cyber criminals can listen to the address of an unauthorized device by eavesdropping the traffic, and then connect themselves to the network with the address of the authorized device. Another well-known security mechanism that's proposed to be applied working and configuring wireless data networks is to hide the network name. The network name, this is the ESSID. This is a proposed mechanism which says that the devices that want to connect to a network need to know the name of the network. So only devices that know the network name, that know the ESSID, can connect to the network. So the ESSID must be entered manually when setting up the connection. But also this is not very efficient. And the reason is the network traffic and the ESSID can be intercepted and detected with appropriate software. As soon as the ESSID is discovered, then also attackers can connect to the network with their machines. What is the recommendation, the caution when serving? So the general caution when serving is use TLS SSL encryption. When serving on public networks, you should be aware, you should be principally aware that everyone can listen what you are doing, and even if you use this mobile network only to connect to the stationary internet and to your station there, you need to be clear that in this entrance point, in this wireless LAN, it's possible for everyone to listen what you are doing. Even if a public network is encrypted, for example in a restaurant or in a hotel Wi-Fi, everyone in that network can read along. Therefore, sensitive data should only be accessed via encrypted connection. Ensure that you are serving with HTTPS. This is HTTP over TLS SSL. Therefore, sensitive data should only send via encrypted connection. I said it already. Be sure to use an TLS SSL connection, particularly when you're inputting user and password data. If you should use this TLS SSL connection on the login page itself, already by your login page itself should already be TLS SSL secured, and not only after the login took place, because the login data are very sensitive. Be sure that TLS SSL connections are used to connect with the email server. So your email program should be configured in such a way that only such TLS SSL connections are allowed. Messenger apps sometimes also use unencrypted connections to communicate. Be very careful when you use this. Some successful security mechanisms are virtual private networks. The use of such encrypted data tunnels, virtual private networks called VPNs. Not all services and websites are available in an encrypted form, so an encrypted communication channel in the form of such an VPN can protect all data, so one needs to access the service by means of such an encrypted data tunnel. Such a VPN is a virtual encrypted network built on existing open networks. It encrypts the data stream, which is sent over a normal unencrypted connection. In this way, we speak from tunneling. So an open, for everyone accessible data connection line is used in an encrypted way. So a secure internal network can also be made available to remote users via VPN if you want to allow, for example, home office work and access with a system from a public wireless network. By means of such virtual private networks, there is the possibility to connect also to secure internal networks. What you need is the corresponding software which allows to run such an VPN. The problem here is that such VPNs are usually more difficult to set up before they can be used. What are the recommendations? What are the safety precautions you should have? First, speaking about private Wi-Fi's. Here, it's necessary to update the devices to prevent this mentioned crack attack. So you need the latest version, software versions, to be secure against this attack. Then use of WPA2 CCMP encryption in the private area. Then, of course, a strong password need to be selected, and this is not a problem because this password need to be entered only once in the device. And then the VPS switch should be off at the router so that over WPS there is no way to attack your device and your data and your content. Optional recommendation is to hide the ESSID. This is not providing a lot of security, but it makes a little bit more difficult for the attacker to see what kind of data you are sending and to listen what you are doing. When we speak about public Wi-Fi's, Then one should use an encrypted connections and foregoing unencrypted services when sensitive data is exchanged. Better way is to use a virtual private network when running such public networks. So wireless networks are very convenient, but you have to take special care about using such Wi-Fi networks in a secure way.